Hello students, welcome back to this new session on mathematics. I am your mathematics teacher from AITM Bhatkal. In this session again I will be continuing the same topic of Laplace transform. Okay, in my previous session I was doing with the Laplace transform. We were working with the Laplace transform of some standard functions. We did for cos, hyperbolic at and e to power at. Okay, first in the beginning we worked for e to power at, then we worked for the Laplace transform of cos hyperbolic at, and I had given for sine hyperbolic at as homework for you. I hope you all have worked for that. Okay, just work for it, and it's very simple. Within 2 or 3 steps you will get your answer. Okay, because Laplace transforms are all the easiest of all the topics in the mathematics. Only thing is that you should be you should be perfect in integration. If you are perfect in integration, you can easily work for the Laplace transform. Okay, and it is not that difficult also. Okay, so let us continue in this the Laplace transform of some standard functions. Okay, here you see. In this I'll be working for the Laplace transform of cos at. Okay, so solution. So the solution goes as, let us write basically what is Laplace transform of f of t first. As usual we do that. Okay, so that we can use it. Now since we are working for, by now you must be remembering, we have worked for so many times the Laplace transform of any function is defined to be integration from 0 to infinity e to power minus st. This is only the extra term, rest f of t dt will come, and integration from 0 to infinity. Okay, this is the Laplace transform. So we will directly apply it for cos at now. So cos at, Laplace transform of cos at, it is nothing but integration from 0 to infinity e to power minus st cos at dt. Now you know this very well. Already have solved one problem in this sessions only. I think the second session itself we were working for cos, and this formula I had already given to you in that video. You can also check that. So its integration is e to power ax divided by a square plus b square a cos bx plus b sin bx. Okay, so here again I'll be using the same. Just see that. Is it not the same? Because in place of t you have got x over here. In place of a here you have minus s. In place of b you have a. Okay, so you are going to use this formula to work for this problem. Okay, now this is equal to, let us apply directly the formula. Let me write here a is minus s and b is equal to a. Use that substitution and substitute it in this formula. So it will be e to the power minus st divided by a square plus b square. It becomes s square plus a square, because in place of b you got a. Okay, this into, take a bigger bracket here, this into a is minus s cos at plus b is a sin bt, sorry, a sin at, this from the limits from 0 to infinity. Okay, you will get it up till here. I hope it is clear to you. This is direct the formula. I have used it in previous sessions also. In class also I have seen it a number of times. I am directly using this formula to work for the Laplace transform of cos at, and just by using that formula we need to just substitute now. Let us put the upper limit. Now as usual I have told it a number of times in previous sessions also. When you put t as infinity over here, what will happen? E to power minus infinity you will get. So no matter what is this bracket resulting for you, this becomes 0, because e to power minus infinity is 0. And when this becomes 0, 0 into this bracket becomes 0 for us. Okay, so it means what? Upper limit, whenever you have e to power minus s into t, if the upper limit is infinity there, always it will be 0. Just remember this thing. So upper limit is 0 there, minus the lower limit we are going to do. Minus the lower limit, t value is 0. So e to power minus s into 0, it will become e to power 0, which is 1. E to power 0 is 1. 1 divided by the denominator as it is into minus s cos 0 you will get, because you are putting t as 0. So a into 0 is 0. So cos 0 you will get, plus a into sin 0 you will get. Okay, now this is equal to minus of minus plus, sin 0 is 0, cos 0 is 1, minus of minus plus, you get s divided by s square plus a square. This is the Laplace transform of cos cos 80, not hyperbole, cos 80. So similarly, I shall write it here, just continue here only, because I hope it is seen there. Now it is seen. Okay, so it is s divided by s square plus a square. So it means what? The Laplace transform of cos 80 is s divided by s square plus a square. And how we work for it? We simply use this formula. You need to remember this formula. Otherwise, there is one more way to solve for it. You know the cos 80. You can write it as e to power ia plus e to power minus ia divided by 2. You can even use this formula to work for this. Okay, you can even use this formula like how we had worked for cos hyperbolic 80. The same way you are going to work for cos 80 also, but in this case you are going to use ia over here. Only that is the difference. Rest everything is same. Otherwise, if you are unable to remember, that is the only thing. If you are unable to remember this formula, then you can apply this formula there. Okay, but in either ways you have to either remember this or this. So it is better if you within one step you will get if you remember this formula. Here also it works about two steps extra, you will get your answer. Okay, it is not that difficult. Okay, similarly, try to solve for, I'll give one more as homework. Fifth one, homework for you. You obtain the Laplace transform of sin 80. Okay, now as per it should be equal to a divided by s square plus a square c. You should end up like this. Okay, there also you are going to use the formula like this. You have to use the formula. I'll give the formula there. Do it yourself. Integration e to power ax sine bx if you are having dx. The formula was, I had given it in previous session as well. I don't remember. But in class I have given you e to power ax divided by. Remember in session I have given or no, I don't remember. Just take this formula and work for it. It is e to power ax divided by a square plus b square. A sine bx minus b cos bx. Okay, this is the formula for to work for Laplace transform of sin 80. Okay, use this formula and get. Otherwise, you can use this formula also. Like for sine, how will you write sin 80 in place in terms of this ia minus e to power minus ia divided by 2. Okay, so this way also you can work. Okay, so just work for this till then. Thank you.